My name is Philip Heedy. I'm Senior Product Manager for ArcGIS Enterprise, and with me I have David Cordes, one of the lead product engineers on the Enterprise team. And between the two of us over the next hour, we'll try to walk you through tuning and scaling ArcGIS Enterprise. What does that even mean? What are the considerations? And then some very practical aspects of that, showing you some specific real-world things you can do right here and now. We're getting late in the conference, so we've had a lot of really good sessions already. I hate to bring up the session list and tantalize you with the things that you've missed, but nonetheless, this serves as a good list of other sessions that are related to this topic. We cannot cover everything in 1 hour. So in about a month or so, we'll start having sessions show up on YouTube. Esri publishes out quite a lot of the sessions here from the user conference, not all of the sessions though. The first one up top, ArcGIS Enterprise Architecting Your Deployment. I've done this twice this week. There's already a version of this presentation out on YouTube, and it's not terribly different from the version I've done this week. There's a few updates for 10.6 and 10.6.1, but the one that you can find from March in the Developer Summit covers the whole spectrum of architecting an ArcGIS Enterprise deployment with all the components. Earlier this morning, we had a session on best practices for layers and service types, very closely related to what we will be talking about here, but more from the perspective of your publication strategies. Do you use map services or feature services or vector tile layers and so on and so forth? In this session, we won't get to that level of detail. What we will be talking about is when you have published your services, what are the things to keep in mind? And then when we get into real-time and big data, we've had lots of other sessions, and I won't even get started on the immense number of geodatabase level sessions. So the geodatabase, of course, feeds into all of your services, and is a very key part of getting good performance out of there. But we can't cover that particular aspect in this session. There's lots of other places to get that kind of information. So with that said, we'll cover all the different components and tiers of ArcGIS Enterprise. That means ArcGIS Server, your traditional services, the engine behind the scenes that powers everything that you're drawing on your map, all your analyses. We'll talk about service authoring, what to keep in mind, because it starts at that level. This is not just about, I have now got a bunch of services and I need to make them run faster. Sometimes you need to take a step back and look at how were those services authored to begin with. Did I even need to create those services? Optimizing individual services once they're there, tuning the system for when you have many services for some relative definition of many. Then we'll also get into Portal for ArcGIS. There's a lot less tuning required in the sense of how much content I have, how that impacts you, but there's some other functionality to be aware of, things like backup models. And then finally, we'll also talk about ArcGIS Data Store, the third component, major component of the ArcGIS Enterprise stack, how that fits into the scheme of things and what to keep in mind there. All right, with that said, I'll hand it over to... Nope, the next slide. I've got the next slide as well, yeah. Sorry. Yes. Before you even get to the point of tuning anything, you've installed the software. You've installed the software on some kind of infrastructure. That infrastructure can be pretty much anything under the sun. ArcGIS Enterprise is software that runs anywhere you can install software that meets our system requirements. That means the machine under your desk, hopefully not. Anybody with the system, production system under their desk, or is it just me and Redlands? All right. A traditional data center, whether it's virtualized, bare metal hardware, or in the cloud. And your choice of where to install the software is often dictated by whatever your organization has available, but it certainly has a big impact on not just how to architect the system, but in many cases also how the system performs, runs, and what you need to keep in mind for tuning. Because these different environments have different options available to them. ArcGIS Enterprise, the full software stack, is very reliant on files stored in different kinds of directories. The portal stores in what we call the portal content store. The server has a configuration store with configuration files, but the server also has lots of directories where cached services have their bundle files stored, where geoprocessing jobs store their intermediate files as well as their results, and so on and so forth. All of those files have to go somewhere. And in a traditional on-prem environment, that's often a file share of some kind, or maybe a file share backed by a NAS device. Those kinds of things matter. We won't get into too much detail on how to make that particular selection, but I want to just make the point that you need to provide good infrastructure. If you have an unreliable file share, for whatever reason, the system is not going to behave well. If you consistently lose network access to that underlying file share, that's not a good thing. The system will get wobbly as a result. So the foundation for everything that we're talking about is having good infrastructure. In the cloud, that means you have even more options. If you're running in AWS, in Amazon, you have the ability to store a lot of the content that we're talking about here in S3 buckets, the portal's content store as an example. That's a great way to get a very reliable, highly available file share, essentially, available without having to set up any infrastructure. You simply create your bucket, point to it, and you're done. And that's a very different experience from having to procure a NAS device, figuring out the right NAS device, paying a lot of money for it typically. All right, with that said, I'll hand it over to David.
Thank you, Philip. All right, so I want to talk a little. Can you guys hear me in the back? Yeah, okay. So I want to talk about map authoring first. One of the things to realize is a good desktop map that you're viewing in ArcGIS Desktop, ArcMap Pro for ArcGIS, may not be a good server map because they're serving different purposes. With server, it's all about how many maps can I get out, how quickly can I get, without compromising quality or the value of the map. A map in desktop can be used in a multitude of ways for a multitude of purposes, right? So your map that you create in desktop and you share an MXD with your coworker, well, it might be used for editing, it might be used for doing some deep analysis, it might be doing for visualization. With server, a lot of those things are more constrained. If you're making a map service, it may just be for visualization. So when you keep those things in mind, you can do things that can optimize it. So one of the first things is probably scale dependencies. Now, I'll say that's probably a good practice for desktop as well. Wouldn't you agree? And one of the things that's interesting is this is one of the things that you can tell by looking at maps on the internet, how many people are doing this. And if you go to like the national map of the US that's put out by the US Geological Survey, they use this all over the place. They have a very good map. And you'll see that with many organizations, they have great maps with scale dependencies. A lot of times, if you're making your map, you plan for which scales you want your map to be viewed at. Pick 2 or 3 or 4 of those. Create a group layer, set the scale dependency on the group layer, then put your layers inside of it. So I would say that's the first thing, because a lot of times you don't want to make users turn off layers in your map. I'm just curious, just by show of hands, how many of you have a lot of maps that are, before I ask the question, there's 2 types of map services. Some map services are designed for a particular application for a particular use. Sometimes, no, I'm just creating a map service, I'm sharing with my colleagues, and they can do whatever they want with it and whatever client they want to do with it. I'm thinking most people are in the latter, but I kind of wanted to get your sense. How many of you have maps that are designed for a specific application? Quite a few of you, actually. And probably almost everybody has a map service that's just for general use for my colleagues to look at. Is that true? Yeah, okay. So one of the things is if you know how your map's going to be used in an application, you can definitely do some things to focus it. One of the things that you can do is you can hide fields. You're like, well, because every time the features are retrieved, every time a query is done, and if you have 80 fields in your layer, all 80 of those fields are going to be retrieved. And that's just a huge amount of overhead in terms of the amount of stuff being sent back. And if you're really not intending all your data to be sent back, well, limit the fields, hide the fields in your map before you publish. Another example is removing unneeded layers. In that desktop case we talked about, a lot of times you put in a lot of layers because you know your colleagues might want to compare and contrast 2 different layers. They want to see things on top of it. So a lot of desktop maps I see have in excess of 100 layers. Does that sound like anybody in this room? Yeah, right? those don't always make the best server maps, right? Maybe if you know your map's going to be used in a particular application and you know what your application's purpose is, you might be able to limit it to 50 layers or 30 layers or a much smaller number of layers, and you can remove some of those layers. Just remove them from your map. Why even make it possible that somebody's going to load and hit those layers? Another example are definition queries. So if you know you're going to hide particular fields, when you query your data, you can define a definition query and hide data that's unnecessary. And then finally, annotations over labeling, right? Labeling placement is actually a very computationally expensive operation. When you're putting down labels on features, you got to make sure there's no collisions. Annotation generates it, decides in a particular position, and then you don't have to go through that computation. So it's worth considering. And then finally, this one is one of the ones that I've seen has huge amount of benefit, is using the same coordinate system for your data frame and your data. Otherwise, on every single request, the map service is going to have to reproject your data to match the data frame, right? That's expensive, right? Reprojecting data, especially if you have polygons with thousands of vertices, you don't want to go through that. And then finally, I'm going to throw in this last one for people for the pros in the audience, is there's this cache control max age property. I'm just curious, has anybody ever heard of this property before? Oh, I actually got some hands. Excellent. This is a property that you can set on your map service. It's kind of hidden, it's kind of buried. It is in our documentation if you want to look it up. But the main thing this does is this is a way of telling our clients that this map isn't going to change for a certain amount of time. By default, this is set to 0, meaning that clients that are aware of this will, every time they need to check and get a map for the exact same map, exact same extent, exact same properties, it'll go back and get it. Even if it got that same map 20 seconds ago. So that's an expensive operation. So what this allows clients to do, like ArcMap or Pro or Chrome or whatever you're using, it allows them to say, listen, I just got that exact same map a certain period of time ago. I'm not going to go back and make another request. So this is a pretty useful feature. You can set it to something like 5 minutes. You can set it to an hour. You can set it for 2 days. It all depends on how often your data changes. But it's a very nice property. And then when this is set, even if it's exceeded that time period, the client will do it in a smart way. It will check what's called an E tag. It will say, I'm going to send a request and ask if this data has changed. ArcGIS server will tell it. If the data's changed, it'll send back the new data. If it hasn't changed, it'll say, you already have the latest data. I'm not going to send it and waste your bandwidth. So this is a nice option. Do any of you guys work on networks that are really slow, like super slow, dial-up slow? Yeah. If you have slow networks, this is a good option to turn on for your maps. Yeah, question? The question was, does this work for feature services in Collector? This option will be used for feature services. Whether a client honors the setting is dependent on that library. I don't know for sure that Collector does honor it, but I would guess it does because it relies on underlying libraries provided by Android and iOS.
So I think a really nice way to summarize that one is the cheapest request is the one that you're never making,
Yes.
right? If the server never has to draw anything, never has to return any data, that's about as cheap as it possibly gets. So this is a way to get that kind of behavior in the system.
Yeah. Some other considerations. I think match the resolution of your feature class to the accuracy of your data. So a lot of times when you create a feature class in ArcMap or Catalog Pro, it sets the resolution to something that's sub-millimeter accuracy. Like it's saying, this is the resolution of my data. And when you throw your data in there, it just says, okay, I'm assuming that's what it is. But most of you probably do not have sub-millimeter accurate data, right? And so if you know what the resolution of your data is, put that value in because that will help the software, first of all, combine points that are really essentially the same. It will also help in terms of the performance and the generalization of the data. Next thing is, for file and enterprise geodatabases, make sure to index your data appropriately. So if you know you have a specific application and you know there's a particular query that's going to be executed against a certain field a lot, index it. That will allow our software to look up and return values more quickly. And then finally, if you're using an enterprise geodatabase, do most of you know that there's different spatial types with the databases? If you're using SQL Server, there's only one. You don't have to worry about it. But if you're using Oracle or Postgres or DB2 or Informix, you have some choices when it comes to spatial data types. I'm not an expert on that, but we have recommendations in our documentation as to which spatial types to use. Make sure that you follow those recommendations to get the best performance. Because what happens a lot of times with spatial types is it also influences how that data is indexed and how fast we can do things like spatial extent queries and how fast they return. I want to talk about, thank you, Philip. I want to talk about file geodatabases briefly. So I'm going to state this, that file geodatabases are better than shapefiles.
Does anybody disagree with that statement?
Yeah, I was kind of waiting to see if somebody was...
Come up afterwards and we'll talk.
Yeah. Shapefiles are old, they're great, they're the standard, but file geodatabases perform a lot better. They scale a lot better. So if you're serving out data with shapefiles, move it into a file geodatabase. It really doesn't take you long to do such an operation. I'm going to say that local file geodatabases is the fastest data. Now, I used to get people who go, what about ArcSDE? And this is not to say that remote file geodatabases are better than ArcSDE, but I'm saying this is data on the machine. There's no network call that needs to be made. This is data that's local on the hard drive. It's going to always outperform remote storage. So it is the fastest way to do it. The other nice thing about local file geodatabases is it scales as you add machines. So if you just have one machine, no problem. But if you add 3 machines and you have a file geodatabase on each machine, there's no extra demand that's put on your network to go and get data from a database. There's no extra demand put on a database or a file server. So it scales really nicely. Now, the downside, as you guys know, with file geodatabases that are copied on each machine is the maintenance, right? If you get an updated file, if you have updated data and now you have got to go copy it on all your machines, that can be a hassle. You could make a mistake, and sometimes your map is giving some data and sometimes it's giving another, depending which machines. So there's a little bit of overhead on the management if your data is changing frequently. So if you have data, especially if you have data that's live, that's being edited by your users, you don't want to use file geodatabases in most cases, right? But if you have data that's not changing, like census boundaries, zip codes, great with file geodatabases, right? And then finally, one other tip is if you want even better performance, you can make the file system on which the file geodatabase is located, you can make it read-only, and you're probably going to get a 10% or better boost in your performance. The reason is the file geodatabase takes a lot of precautions to make sure that somebody's not writing at the same time that somebody's reading, right? You can cause corruption. So it has all this locking mechanisms. Once you make it read-only, it knows that nobody's writing to it, and it's optimized. It performs much faster in that case because it doesn't have to worry about that. Thank you, Phil. Finally, let me talk about enterprise geodatabases. So again, they're fast, so the ArcSDE people won't get upset, but it's true. It's also great with live data. The downside is it requires a database expert, right? If you're going to manage a database, you got to make sure it's up. Otherwise, when it goes down, your data's down. One recommendation I'll make is what I will call, well, let me level set. How many of you guys know what I mean when I say version data? I'm assuming most of you are database geeks. Yeah, okay. So what you know and love is versioning. I'm calling traditional versioning, just because it's not a term that's standardized, but I want to talk about that. That type of versioning works really well for desktop editing. Doesn't work as well for server. There will be performance problems even if you're editing. Now, some people have the perception that, well, I'm editing this data, so I need versioning. At one point, that was true. It's not true anymore. If you're using archiving, if you're in a recent version of our software, that's also not true. You don't need version data for that as well. What's new at Pro 2.1 and ArcGIS Server 10.6 is branch versioning. How many of you have heard of branch versioning? Not as many. So this is a new way of doing versioning that's specifically designed for better scalability and for multiple concurrent users. The problem with the traditional versioning, it was really not designed for scaling with having lots and lots of users simultaneously editing. Okay. Other things, you want to keep your statistics up to date, right? Because that's how we optimize our queries. And then, of course, you want to index fields that you're going to be querying. All right. You want to take this one?
All right. Thanks, David. So now we move into talking about how to tune your services. How many of you are familiar with SOC processes? This is our kind of crowd, David.
Yeah.
Everybody knows what a SOC process is. All right. So we have two models today within ArcGIS Server. We have what's known as hosted services, and then again, like David just said, this is not an official term, but let's just refer to them as traditional services, the things that are not hosted by the system. I'll talk a bit more about here in just a second what I mean by hosted by the system. Traditional services are what's powered by SOC processes. So these are the services that you have published from ArcMap or ArcGIS Pro, referencing data in place, referencing the data that you have in your enterprise geodatabase, one of these file geodatabases we just talked about, or heaven forbid, shape file somewhere on disk. We know you're out there. We don't judge much. When you do that, you get one of these services, and you now have a number of options in place that we'll talk about here in just a second. Now we need to talk about service instances, min, max. That's the main thrust of things. But the important thing is to understand that these services, this is always the model that's used when you're referencing your data in place. Now, here's the aside that I just mentioned. We have these two models. We have hosted data, and we have referenced data. Another way we often talk about this is there's user-managed data. This is the reference data where you are responsible for managing the data store, the location, wherever this data is coming from. You are running the database, SQL Server, Oracle, Postgres, and so on. You are managing the file share where that file geodatabase or those shape files are located. We get a lot of questions on this, and often phrased as, why is Esri trying to kill off my enterprise geodatabase? Or maybe you say SDE, that's also okay, I don't judge. In favor of ArcGIS Data Store. And I'll give you a little spoiler. The answer inside of the white paper is, we are not. That is not something we are trying to do. The reason I point it out here is because it does have some impact on this. There's SOCs, there's these hosted services, and that's all something we try to talk about here in this white paper. Try to give some background and an explanation of why we have both options, why they both make sense, why they're complementary and not in competition with each other. So I highly recommend taking a look at this white paper if you're interested in that topic.
Okay. So I really like this image here. Does anybody know where that photo's taken with all, if you can't tell, those are all cars lined up, and I gotta be 60 lanes of traffic, a huge traffic jam. Does somebody know where that picture was taken? Shout it out if you know.
Tesla.
What?
Tesla.
Tesla? No. Border? No, not. It's not the U.S.-Mexico border. China, yes, that's right. This is a Chinese traffic jam of epic proportions, right? And you can see what the problem is, right? There's these 60 lanes of traffic that are essentially merging down to 20 lanes of traffic, right? Doesn't that look like a nightmare? So now this is relevant for this slide because we're going to talk about instances. Instances are a lot like lanes of traffic, right? They allow you to handle incoming requests. Now, you would say, well, okay, well, instances are great. They handle more requests. Why don't I make more instances? Why don't I make more lanes? Why don't I have a 60-lane freeway? Because you don't have the space, right? Obviously, they couldn't keep the 60-lane freeway going up for too long. What happens is, with instances, each SOC process uses somewhere between 100 and 200 megabytes. It can be larger for some services. Geocode services tend to be large because they load a lot of data in memory to be fast. But that memory is being consumed whether you use that service or not. So if you have a service that has one instance standing by at all times, it's ready to go. It has all that memory being consumed so that when a request comes in, it's ready to go. But it's going to be consuming those 200 megabytes of RAM no matter what. Now, the number of instances you have, like I said, allows you the number of concurrent requests that can be serviced. So if you have more of them. So there's this trade-off that you're making. You're making a trade between how much memory do I use versus how many requests can I use simultaneously. And that's why we don't, at Esri, have automatic, like, we're just going to pick a number and just tell you that's the right number. This is a human endeavor. This is something you know your data, you know your users, you know your use patterns, and you can make the best call. You also know the relative importance of different services. You might say, well, this service, I cannot have it be slow, so I'm going to give it more instances. This other service is like, yeah, we need it, they can wait a little bit, but not at the cost of this service. So it's worth thinking a little bit about how instances requests are handled in ArcGIS Server. We're going to go a little bit into how we built the server. So when a request comes in, you're at your browser, you make a request for a map. That request gets sent to a web adapter, a load balancer, some entry point, right? And then that web adapter, that load balancer, is going to send the request to one of your ArcGIS server machines. Maybe you only have one, but it's going to send it to that machine. When it gets sent to an internal component, an internal part of our system called the handler. We have a REST handler, a SOAP handler, OGC handler for WMS, WFS services. And that handler is going to hold on to that request until there's a free instance to handle it. So it's in the waiting room, and that's why this picture is up here. It's waiting for one of the instances to be free. If there's one free, it immediately goes right into one of those SOC instances. Otherwise, it will wait, usually by default, up to 60 seconds for an instance to become free. Usually an instance becomes free in much, much sooner time than 60. Most of the time, it will just go right in and get a SOC instance. And of course, if it gets worked on, that SOC instance will be sent back. So the good news is, if you don't have enough instances, your user requests are not going to fail, unless you just have way too few instances. They may have to wait longer, but their request won't fail. They may have to wait, if the request takes normally a second to process, they might have to wait 3 seconds, because they might have had to wait for the people ahead of them in line to finish. So it's important to understand that, because when we talk about the instance tuning, that's what we're going to have to think about. So the first thing I'm going to recommend, before I even talk about that, we let you pick a range. We say this service can have between 1 and 5 instances, or between 3 and 4 instances per machine. We give you a range. And we do that because some services are highly peaky, highly variable. Some things may be seasonal, right? So you're like, okay, I don't want to manage instances all the time. If there's a big flood of people all requesting something, use as many resources as you can. And then after the flood of requests, scale back down. Don't use that amount of memory. I would say in most cases that unless you're in that peaky workflow, that a lot of times it's really best to use the min equals max. And that's because you get predictable performance. Like, you will typically know how your service is going to perform, because you're not going to have a time, for instance, when a bunch of extra instances are getting spun up and they're all competing for resources. You will know typically how your system's going to perform. The default is min equals 1 and max equals 2. We have to pick a default for you. It's not a bad default, but you really should consider thinking about, do I really need 1 instance? Or do I need 2 instances or 3 or 4? Think about this when you publish. It's one of the things that has an impact on your performance. Unfortunately, a lot of times the people who author the services aren't the people who are thinking about performance, right? It's you people in this room who are thinking about it, right? So take a look at your users' choices on this field. A lot of them are just going to go with the default, and they may have too few instances because they didn't think about this. So you may be able to improve their performance on their services by setting this to a higher amount.
Just by a show of hands, how many of you manually tweak your instance settings today?
Oh my gosh, you guys are awesome. I will also tell you, I often engage in conversations with customers and their IT staffs. And some of them believe that the page file or the swap space on your computer is a dirty word. Just 1 second. And what is that? That's the extra space. If you run out of memory, you use up all your RAM, it can put some of the less used programs memory onto disk. And system administrators hate that. They're like, no, if it has to swap memory from the hard drive and put it into RAM and down, it's going to kill performance. Well, I'll tell you what will happen if you run out of memory and you don't have swap space. It will kill your functionality. You'll have crashed SOC processes all over the place because it ran out of memory. So I usually recommend that you have some swap space, you have some page file space, because it will at least keep you up. And if you have bad performance, go fix the problem by getting more hardware or optimizing or following these other steps. But don't let your system fail. Now, there was a question over here.
Well, it was more of a comment.
Comment?
We need the min and max adjustment functionality in ArcGIS Pro. It's currently not in the share as service page.
Yeah, so the comment, I'll just record it so that people can hear it in the whole room, is that Pro doesn't have those options exposed. And so, he's requesting that we have that. I'll tell you the thinking behind it, and not to be defensive, but Pro is they're trying to make publishing simpler, and they realize that most authors of maps don't ever change that. It's usually the system administrator who comes in later and fixes it. But I got what you're saying, and I think it's worth having that in some kind of advanced options thing for people to be able to specify that.
Last night I made an idea on the idea page.
Excellent. Actually, people do look at those ideas pages. So, and there was another comment over here.
That's my job.
Yeah.
I just have a question about, when the swap space is used. I can use a case where we're doing a lot of processing in memory, but the swap space is also getting full. It's a performance problem because, we're writing to the swap space.
Yeah, so the comment was, well, there is a performance issue because he's doing some processing, and some of the processing is happening because stuff's being written into swap space. What should happen most of the time is the active stuff, the stuff that's actually being used at any given moment, should be purely in RAM because the operating system does that. It should be, the things that should be in the swap space, in the worst case, would be those 40 services that have min1 instance that haven't been used for 2 weeks. Those should be the things in the swap space. The things that are actively getting used shouldn't be. So I would say if you didn't have the swap space, your thing would probably be crashing. So it's one of these things where you probably want to take a look at memory. Analysis, I've been treating the memory like it doesn't change, but in fact it does. It's, have an idle amount of memory, and then when you're processing stuff, of course, it's going to need more memory to do that analysis. And analysis especially can be pretty demanding because it has to go through a lot of stuff. Another comment or question?
Yeah. So, but occasionally we'll get a SOC process and we look at the task manager that just is eating up everything. And it's hard to track down what process that SOC is related to. Is there a good way to do that?
Okay, that's a very good question. I'll repeat it, and then I'm going to ask that maybe most of the other questions we will hold to the end, just because I want to make sure we get through it. But the question was, SOC processes, it's hard, and you can see there's a bad behaving SOC process in Task Manager. How do I know which service is that's affecting? I'll give you a tip, is in Task Manager on Windows, there's the command line column or field, and you can use that and expand that out so it has like 30 or 40 characters, and you'll see the service name in that command line. And it's actually not even used by our product. We purely put it in so that people can analyze and identify SOC processes. in an easy way. So that's a way to do that. Okay, one last question.
On the next page, on the processes, there is this option for high and low isolation.
Yes? Okay, that was intentional. The question was, on another tab, there's low isolation and high isolation. We have intentionally not mentioned that in this session.
What version are you running? Let me ask that. 10.3.1. Yes. You will not find that option beginning at 10.5 and higher.
Yeah. So let me explain what it is just briefly. You guys are all fairly advanced, so you probably have all said, like, what is this high isolation or low isolation? The idea was, well, maybe I don't need as many ArcSocs as I have running. So if I have 4 instances, I get 4 ArcSocs if I have high isolation. With low isolation, you can say, you know what? I want all those 4 instances to run within 1 ArcSoc. And we initially put that in back at 9.0 because we were like, boy, people are so constrained on memory. This will save 3% of memory. You know, it was like, whoa, this is really a micro worrying about memory. It really does not save much memory because within that process, if you're computer science, there's different threads, and those threads basically have all their own objects. And so they does consume basically almost the same amount of memory. If anything gets a little bit slower, there's some risk that things crash. So we, like Philip said, we got rid of it. We don't even expose that anymore. So we're in an age where computers routinely come no longer with 1 gigabyte of RAM as it did at 9.0, but they come with 16 and 32 gigabytes of RAM. So it's not worth using that. Okay, so instance tuning. So I'm going to go through this quickly. Let me know if you have any questions on it. But you want to avoid overloading, right? So when you overload a service, you don't want to overload your service. You don't want to have one instance handling literally thousands of people all accessing that service at once, because that thing is just going to queue up. It's going to kill your performance. At the same time, you have this other balance, right? You don't want to over-allocate either. Now, I think one of the misconceptions is that, and I see this all the time, is, well, how many instances do I need? It's how many concurrent requests you have. So somebody says, well, I'm going to have 10 people in my department using this map service, so I need 10 instances. Now, I can see a lot of you are like, I know, I see the fallacy in that, right? Because those 10 people are not going to be hitting and sending all requests at the same time, right? You may only need 1 instance to handle those 10 guys because they're panning, they get the request, they're looking, they do another request. So you may be able to get by with a lot less instances. It's concurrent requests that matter, not concurrent users that matter. So don't automatically create a ton of instances. The other fallacy I'll make, just make sure you guys understand this, is those instance settings are per machine. How many of you have more than 1 ArcGIS server machine in your site? Just to get okay, this is worth mentioning then. So if you say I have 2 min and 2 max instances, and you have 3 machines, you have 6 instances available to handle request. Because that's 2 instances per machine. That's not your total number of instances, it's the number per machine. We did that so it could scale easily. Every time you added a machine, you didn't have to go rejigger all your instances. So just be aware of that, because that's the other thing I've seen is people will sometimes think it's the total number of instances, and when they add machines, they end up with way too many instances. They have 18 instances because they thought they needed to say 6, and it was just wasting memory like you wouldn't believe. So one of the things also to look at is services with many layers, like having a few services with many layers or many services with few layers, right? In the former, few services with many layers, you don't need that many ArcSocs. You're not using that much memory, right? But you're now giving people a big catalog of instances or layers to choose from. I think that's really useful, especially if you have people who are using your services in like ArcMap or Pro, a thick client, where they're going to be picking and turning on layers. Now, if you have many services with few layers, well, like I said, those things might perform a little bit faster, right? Because not all these layers are going to be turned on. But then that's usually better suited for a focused application. So that's something to think about. And then finally, the last bullet point, min equals 0. So you can say, you know what? I don't want this service to be ready to handle the first request that comes in. When that first request comes in, I'm going to start an instance at that moment. And the time it takes to start an instance, it varies, but it could be 5 seconds, it could be 10 seconds, right? It could be 20 seconds. So that first request, they may have to take a hit. They may have to wait a little bit. But boy, that really reduces the amount of memory you're using, right? Because there are services where people are going to use them for a little bit of time, once a week for a 2-hour period. They're not going to use it the rest of the week, right? This is great for that, right? Now, but I would generally say I wouldn't use this option because people complain. People have slow performance. They think it's not working. How many of you are impatient people? Like when you see the web page didn't load in 3 seconds, you click refresh, 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 right? Well, that's what these people do too, right? Well, the service didn't work. Usually it's fast. Refresh. Now the server's like trying to handle 5 requests, right? Because you had impatient users. And I imagine you guys are probably more patient than most of your users, maybe? Yeah. So
there's even a small other subtle detail about min equals 0 that I'm always a little bit leery of. And that is, if you have a lot of min equals 0 services, yes, you're setting yourself up for potentially a bad situation if all of those services all of a sudden get a request. Your system is sitting there idle, good, you have plenty of memory, and then for some reason, all the stars align and 20 different services that are at min equals 0 all get a single request. And all of a sudden, your system has to be able to spin up 20 SOC processes. And you've just used gigabytes of memory that you probably weren't planning for. You used min equals 0 because you were running low to begin with, right? So it's a dangerous situation. You're basically crossing your fingers and hoping nobody will ever actually do this. And if they do, it's going to be very isolated, just 1 or 2 here and there. If or when that assumption gets proven wrong, you're now in a bad situation.
Yeah, and I will tell you that, true story, I had somebody who got ArcGIS Monitor, right? ArcGIS Monitor is a great component, right? They got it, and they said, I'm going to monitor performance. And once they started using it, like, my gosh, my server's crashing a lot more than it ever did because I'm using ArcGIS Monitor. I don't understand why.
Oh, yeah.
Because they had 0 instances, and ArcGIS Monitor was testing the performance of every one of those services, which was spinning up a SOC, which was causing it to run out of memory, which was causing crashes and all kinds of weird behavior. So it was just because of the hidden detail there. Okay, let's go on the next one. So tuning your web map. So now we're talking about web maps within your portal, right? So web maps themselves, there's not that much you can tune with them, but there's a lot of behind the data. So let me talk about a little bit. The first thing is our mapping applications. They care whether the feature service is read-only or editable. And I'll tell you why. A feature service that's read-only or that's editable has to preserve the precision and resolution of the data. Because if you're going to change something on one of the features, it needs to be able to submit that same feature back with that same resolution, that same accuracy of the data. So when it fetches, even if you're not using that, the map viewer doesn't know whether you're going to edit or not. It's going to pull that data down and pull all of that data down. It's going to be a much bigger thing. If it's read-only, the map viewer can say, you know what, I can generalize that data. I can cut off some of the resolution because I know at this scale, I'm looking at hundreds of kilometers and I don't need millimeter accuracy. And so it can render a lot faster and get a smaller footprint. Most of the time when you publish a hosted feature service in Portal, you upload a shapefile, CSV file, geodatabase, and turn it into a hosted feature service, it's going to be read-only. Because Probably that is what you want most of the time. And so it will be fast. But if you say, well, I'm going to edit this, you've now made it a little bit slower. One of the tips is if you're thinking, well, I have this subset of people that I want to edit it, and the rest of the people I want to view it, you can use feature layer views, at least if you're at the most recent versions of our software. And that will allow the people who are editing it to get the full data, that costs a little bit of performance, and the people who are viewing it to get faster performance. So that's a little trick. Another thing, this is just one of these things that some of you may not notice, maybe some of you have the same pet peeve I do, it's default extent. Like when I open a map, that default extent is super important. If I'm looking at a map for, I don't know, Boston open space planning, well, I expect the default extent to be on the extent of the city of Boston, right? And if you don't have that initial extent right, you now force the user through a worse experience, right? Now they got to click on it. And you're also hurting performance. You're having people do a bunch more clicks on their maps. So make sure that you're using your default extent carefully, right? And how is the default extent figured? It's when you save your web map. And sometimes you're just clicking save and you don't even think about what the extent of your web map's going to be. So think carefully about that.
Improve your performance by having the scale dependencies set a little bit inside your default extent so that some of the layers aren't loaded on view.
Yeah, the question was, can you combine techniques? Can you use scale dependencies in your default? And that's another reason for using your default extent. Yes, you can absolutely combine them. And you should think about at what scales you want your user to be viewing the map. Because yes, it's going to help you optimize it. And so, yeah, you don't want them to be at a really zoomed out extent and then load all this crazy amount of data that they're not going to need or care about, because the very first thing they're going to do is zoom in.
Right. If you're giving them a search where they're zooming into a location as soon as they
Yeah.
hit it, and then they'll load 10 more layers when they get to that extent, are you better off having them start at that extent, or better off having them out where you only draw 2 or 3 layers?
I think it depends on the application, right? So like an example is, if you've used any of our solution products, we have a parcel viewer, right? Parcel viewer is designed so that you put in a parcel ID or whatever yeah, it takes you directly to the parcel, right? And that's the right way to do it. Don't make them go through extra clicks. But you do have some people where they're doing exploratory thing. Like I'm looking at open spaces in Boston. Well, the planning might be all over the city, and so I want to see a whole view of it so I know where I want to look at and focus. So it depends on the application. And then finally, large amounts of data can be slow. One of the things that we've done is, if you haven't heard of have all of you heard of smart mapping recently? So smart mapping helps you aggregate your data and show stuff, because nobody wants to look at 100,000 points on their map, right? What you want to do is you want a heat map. I want to aggregate it. I want to symbolize this in a different way that makes it, to me, consumable as a human. So really thinking about how you design your maps is a key factor, especially if you're zooming out, right? People say you may want to show that level of detail when they're zoomed in, but when they're zoomed out, you might want to show an aggregation. Show them the areas of the city that you are doing the most planning. And then finally, I'm going to put a plug-in for quantization. That's in the newest release, the 10.6.1 release, coming out next week, I think, right?
July 17th, yes.
July 17th, which helps you do on-the-fly generalization and really reduces your data transfer.
Just to put that one into perspective, for those of you who weren't at the session that I did this morning with Whit, we showed a demo of all of the counties in the United States, putting them on the map as a feature layer, and using non-generalized data, meaning just getting the raw geometries for all of them. First of all, it takes a while to just draw that on the map. You can feel the browser getting sluggish, all of these things. And we showed how we were actually downloading 26 megabytes worth of JSON. That's a pretty decent chunk, even on a fast network. Once we turn on quantization, we used 10.6.1, we used an application where we had turned on the WebGL rendering and the JavaScript API, lots of cool little things that need to line up. Instead of downloading 26 megabytes worth of data, we were downloading 400 kilobytes for the continental United States, showing the exact same thing with a super slippy map, fast experience. It makes a huge difference. And that's the difference between raw geometries, generalized geometries, and now with 10.6.1, this quantization, which is a new way of doing generalization. It really makes a big, big difference, and it's worth looking at. It's one of the features that I'm really excited about for 10.6.1, kind of on the geeky backend side of things. Yeah. All right, we'll move on to another aspect of tuning your web map. Today, a common setup that we very often see is that you have a data set of some kind. This is a feature class in your enterprise geodatabase. And then maybe you want to give out a couple of different views on top of this feature class. Some users in an application somewhere needs to look at the full data set. Others need to look at a subset, so you publish a service with a definition query on it. Maybe others need to look at yet another different subset, so you publish a third service with a different definition query. And at this point, you've got 3 services on top of a single data set, all of those services backed by their individual instances, using a decent amount of memory. Within your portal, you now have also 3 separate items, 3 separate web layer items pointing to each one of these different services. So this is a great experience from the perspective of discoverability. You can go in, search in the portal, find your layer, add it to a map, do your thing. What I want to give a plug for is what I think is a much better, more efficient setup in many cases. It's not always applicable, but in a great many cases it truly is. Instead of having to publish out 3 separate services and burning in that definition query at the service level, using the portal geoinformation model, you can create additional layers at the portal level, and at the item level have your definition queries. You don't need to publish another service. The definition query is pushed down as part of the request itself. So you can get the exact same experience where different people look at different subsets using exactly one service. This can save you a ton of memory if you have that kind of setup today. And it's a very often overlooked feature. You can do this with not just filtering through things like definition queries, but also symbology. The modern server, for a great many releases, has supported something known as dynamic layers and the ability to actually push symbology as part of the request itself. Instead of having to author the symbology within ArcMapper Pro, the client can make a request for specific rendering options at the time it makes the request itself. So this gives you a lot of flexibility, and you can author these things outside and separately from the service and save yourself a whole bunch of memory. So this is really important. Where you don't always are able to use this functionality is if you start getting into security. Because if you only have the one service, our security model works at that service level, right? So if different people need to see different views of the data, in the case of filtering, maybe, and this actually needs to be enforced at a security level, this may not be the right option for you. But for anything else, take a look at this. It's a really powerful and often overlooked feature. So a concrete example of this could be if you had some wells data. Let's imagine we have a wells feature class with 1 million points in it spread all across the globe, publishing out that one feature class as a single service, and then having a view with active wells, with proposed wells, and a third view of by status. All of this powered by that single service, which is really just a conduit down to the underlying feature class. All right, back to ArcGIS Enterprise and tuning your enterprise portal. Do you want to take this one?
Yeah, I'll do it real quick. So Portal doesn't have a lot of features that need to be tuned for performance, but I will talk about 2 aspects. One of them is I call login settings, or the security settings. How many of you actually use your organization's users in Portal? Whether you're using Active Directory or LDAP or something like that, or SAML. How many of you are using the built-in, like you're creating your own accounts in Portal? Okay. Okay, more than I expected.
50-50.
Yeah. If you're using the built-in accounts, you will get faster performance. But often that can be at the expense of ease of use for users. A lot of times users are like, I don't want to remember another username and password, right? So it's fine to use Active Directory or LDAP users, SAML users. No problem with that whatsoever. Now, if you're using the enterprise users, a lot of times you also want to use enterprise groups. Like you may have a group in your Active Directory for your project or your team or your department. And a lot of times people want to bring those into Portal, and that's great. If you bring too many of those in, you're going to slow down performance. And if you've used this functionality before, you may realize that only administrators can bring in the enterprise groups into your portal. Because we don't want a bunch of users inadvertently slowing down your performance. So I know users who have over 1,000 enterprise groups, and it works fine. But would their logins be a little bit faster if they had 30 groups? Yeah, probably. So think about using that judiciously. The other thing that catches people are backups. So in Portal, you can do backups of Portal. You can do what's called a full backup. It just takes a copy of all your data, all your settings, puts it in a file. Now, and you can say, I'm going to run that every night. But what happens is those backups are pretty large, right? You might have 10 gigabytes of data, and so every day you're generating a 10 gigabyte file. So a lot of people use incremental backups. They say, you know what, I only need to keep track of the things that changed since yesterday when I did that full backup. So I'm going to do incremental backups for a few days. And the one thing that happens, though, is those incremental backups can at some point get bigger than the full backups because it's keeping track of, oh, they created a web layer, then they deleted the web layer, and then they created the web map, and they made 7 edits on the web map, and they made another 7 edits on the web. And so those accumulation of the incremental things grow. So what we tell people to do when they're doing backups is do full backup on a periodic basis. Do it every week, and then do 6 incremental backups on the other days. And that's a good thing. That'll get you better performance when you're doing backups. The other thing also is after you do a full backup, the software is getting ready to do incremental backup. And so it's going to be starting to log those things. So make sure you do a backup on a regular basis, or I think there's an option in Portal to say, you know what, I'm never going to do incremental backup. Don't start collecting all those incremental records. Otherwise, it's just going to grow unbounded.
All right, we're running a little bit short on time, so I'll try to be fairly brief on this topic. We wanted to also cover the ArcGIS data store. So I talked about this a little bit before in the context of the white paper and how it relates to your enterprise geodatabase. But the first and simplest point I wanted to bring up here was really just understanding that there's really 3 types of data stores within the one ArcGIS data store component. The one that I'll talk mostly about here right now is the relational data store. So this is where you uploaded a CSV file or a shape file or whatever it might be to your portal or through some other mechanism, and you created a hosted feature layer. The data for that hosted feature layer needed to go somewhere, and that somewhere happens to be the relational data store. Tile cache data store is what powers 3D, and spatial temporal big data store is what is able to archive large volumes of data from GeoEvent and from GeoAnalytics. ArcGIS Data Store has a great number of command line tools available to it for managing and to some extent also tuning the data store. So this is my one plug because I am going to run out of time before I can go through all of them. Take a look at the documentation for ArcGIS Data Store and these different tools because there's a lot of functionality buried in here. The one tool that I would point everybody to is the one mentioned here at the bottom, the Describe Data Store tool. If you're doing any kind of troubleshooting or trying to understand the behavior, the Describe Data Store basically gives you that current snapshot of the system, the status of what's going on. Is this data store up and running? What's installed and configured on this machine, the relational, the tile cache, how many connections has the system made to the data store, and so on and so forth. And just like with Portal, the data store also supports both full and incremental backups, and there's different tools for managing the schedule for that, support for incremental backups, and so on and so forth. Like I said, inside of the documentation, there's a great topic for all the command utility references, goes through all of these different tools, their various parameters, which data store types they apply to. All right.
Yeah, I'll take scaling. So we're almost we have about 1 minute left on the scheduled time. I think the remaining slides will take about 5 minutes, so I apologize for going over. But I wanted to give you guys some light at the end of the tunnel. So I'm going to talk about scaling direction really quick, just to talk about to use these terms. Scaling up is what I would call you have a machine and you want to add more resources to that existing machine. I want to add more RAM, I want to add more CPUs to an existing machine. Scaling out is I'm adding new machines, so I have more ArcGIS Server machines to handle a request. Usually, especially with ArcGIS Server, scaling up means adding more RAM, right? My services are popular, I got in a lot more services, I published more of them, need more RAM. Scaling out is almost always more machines, and usually it's to get more compute resources for ArcGIS Server. That's when you have so many concurrent requests, doesn't matter how you've optimized your instances, you just can't get all those CPUs are 100% busy or close to it. So let me talk about Portal real quick. The one thing I'm going to say is people ask me sometimes, when do I need to scale Portal? And I'm going to say almost never. I've been working with Portal for a long time with some very big customers. I have one customer I know, 60,000 users, heavily used. They run it on one machine. ArcGIS Online itself has, I don't remember, I asked 2 years ago, had 4 machines for handling all organizations in ArcGIS Online. So it scales really, really well. So I'm just going to kind of move on to the next slide for the sake of time. ArcGIS Server sites, however, it is important to think about the scaling of the ArcGIS Server sites. One of the things you can consider is you can add, when your existing site is pretty big, 4 or 5 machines, you might want another ArcGIS Server site. One of the things that's important in this, I think, is pre-planning. And I know how many of us can look in the future 3 years, but if you have some idea of what's going to be happening to your site, pre-planning is important. The one thing I'll say here is a URL is forever. Once you have a service and you have a URL to that service, it's going to get put into ArcMap in MXDs, it's going to put in web maps, it's going to be put in applications. It's almost impossible to move a service from one site to another site because you change its URL. So when you need to scale and you need to add another site, you're almost always never going to want to move your services. It's extremely painful. So if you can come up with some logical organization, like, oh, these are my geoprocessing services, these are my map services, that will often be beneficial. Scaling existing sites, a lot of times, if you're running out of you have so many services, you're running out of memory, or you're using that swap space, get more RAM if you can. A lot of times, if you're on a virtual machine, that's not an expensive operation. They may have it available already for you. If you need more CPUs, you're going to add more machines. The other plug I want to put in is a lot of times ArcGIS Server scaling problems are not ArcGIS Server scaling problems. They may be problems with other things that ArcGIS Server depends on. The other thing is when you scale ArcGIS Server, you may also need to think about these things. So a lot of times I see bottlenecks on file servers, especially if you have a lot of machines or you have a lot of data and it's being hit by 100 instances all go into that one file geodatabase on your Windows share. You may be hitting a file server bottleneck or you may be hitting a network bottleneck. Also databases. I have run into more than one customer who's just exceeded that poor database. It's handling all these machines, all hitting it. You may need to move some of that data to another database server, or you may need to use advanced database clustering to handle the volume. Now, with that, I'm going to now put a plug in for the survey. I know every presenter says, fill out your survey. I'm going to beg you to fill out your survey because you probably didn't fill it out when the other presenters asked you. Really fill it out in your app. The feedback especially is really important. Numbers are great. Feedback is golden, right? Tell us what we could have added to this presentation, what questions weren't answered, what you'd like to see next year. Those kind of feedback are really useful for us. With that, I think we'll just take questions up at front.
Yes.
So
Thank you so
guys.
much for coming. We appreciate it.